Hi, welcome to my video on the review of square root radicals part 2. This is the videos from number 27 to 39 on my YouTube channel. And as you can see, I have the total is marked out of 29, and I have this is the first page of 5, so there's 4 more pages to come. And how we do a review, I treat it as a quiz. You answer each question one at a time, play pause, see if you're right, give yourself a mark. When you're finished, total up each page, and get the total up each page comes to 29. And then you take the total, divide 29 into it, and change it to a decimal, and then move 2 places to the right to get the percentage. And hopefully you do well. Hopefully you did well on my part 1 video. This is extending it. Here we go. Simplify 6 plus root 5 all squared. So that's 6 plus root 5 times 6 plus root 5. Let's use FOIL on it. And 6 times 6 is 36. 6 times root 5 is 6 root 5. Root 5 times 6 is 6 root 5. And root 5 times root 5 is 5. And to make it quick, let's add these two to get 41, and add these two because they're like terms. You get a 12 root 5. Give yourself a mark if you're right. Number 2, we're doing PEMDAS, so all the insides are root 2s, can't simplify. Root 10 can't simplify. We got no exponents, so we have to multiply these two and multiply these two. Just remind PEMDAS, or bedmass. We have can't simplify the brackets, no exponents, so we're going to multiply these two before we subtract. So let's do the big bracket like this, and we go 3 times 3 is 9. We're using FOIL, and 3 times negative root 2 is negative 3 root 2. 3 times root 2 is a plus 3 root 2. And root 2 times root 2 is a negative 2. Let's multiply this one. We got root 10 times 1, which is root 10. And root 10 times root 10 is 10. We simplify the inside of these first before we subtract. We have to keep simplifying the brackets. This one is already simplified, so we'll do that one. And 9 subtract 2 is 7, and they cancel out. So I have 7, subtract this, so that's a 7. And when you subtract, you add on the opposite. So it's a negative root 10 minus 10. And remind you, that's the same as putting a 1 there and a 1 there. 1 times 7 is 7. Negative 1 times root 10 is negative root 10. Negative 1 times 10 is negative 10. Remember, when you subtract, you're adding on the opposite. And to simplify that, 7 and negative 10 is a negative 3, subtract root 10. Give yourself a mark. Number 3, we have PEMDAS again. We have 3 multiplications. 3 times 7 root 2 plus 1, 7 root 2 minus 4. What I do, I like to multiply the 2 brackets first and then the 3 after. Because when you multiply 3 by this one, you get bigger numbers. So and remember, the 3, if you didn't multiply by the 3 first, you would only multiply the 3 by these two, not by this one. So I like to multiply these two binomials first. Root 7 times root 7 is 7. 7 times negative 4, root 7 times negative 4, negative 4 root 7. 1 times root 7 is 1 root 7. And 1 times negative 4 is negative 4. And we simplify the inside until it's completed. So 7 minus 4 is 3. And negative 4 root 7 plus root 7 is a negative 3 root 7. The inside is fully simplified. Now we go 3 times 3 is 9. And 3 times negative 3 root 7, excuse me, is 9 root 7. Number 4, state the conjugate, excuse me, of root 7. The conjugate of root 7 is root 7, because when you multiply root 7 by root 7, you get a 7. Rationalize the denominator of each. That means you got to multiply by root 2, top and bottom, and that gives you root 2 over 2. You cannot cancel these because that's an irrational number and that's a rational. That's a 2. And B, the conjugate of root 3 is root 3. So you put root 3 on top and bottom to balance it. 12 times root 3, 12 root 3. Root 3 times root 3 is 3. And 3 cancels into 12 4, so you get a 4 root 3. C, the conjugate of root 10 is root 10. Remember, you rationalize the bottom means you're making the denominator a rational number. We multiply, we get 5 times 1 is 5, root 30 over 10. Root 10 times root 10 is 10. 5 into 5 goes once, 5 into 10 goes 2. So that gives me root 30 over 2. Or if you want, you can go 1/2 root 30. Your choice, either or. And number 6, simplify. Well, first of all, I see I have a fraction here, so I can say 4 into 4 goes once, 4 into 8 goes 2. We could do that. And I'm going to simplify the root of 27 because it's 9 times 3. So that gives me 2. The root of 9 is 3, so that's 3 root 3. So the root of 27 becomes 3 root 3. 12 is 4 times 3. So that's a 2 root 3. And if you want, you can cancel, or we can multiply 6 root 3 divided by 2 root 3. And the root 3's cancel, and 2 into 6 goes 3, so that's a final answer of 3. I could go right here and cancel. If I want, just watch. The 2's cancel, the root 3's cancel, they're all 1s, so I just get a 3 left. So I could have multiplied and then canceled, or I could have canceled and then multiplied. Simplify the square root of 4 over 11. Well, we're not allowed to have a fraction underneath a radical, so we break it up into the root of 4 over the root of 11. And when you do that, the square root of 4 is 2 over root 11. So we have them simplified, and we have the rationalize, root 11 times root 11. So that's 2 root 11 over 11. Give yourself a mark if you're right. And the total on that page is 9. Okay, here we go. Number 8, simplify. We're adding fractions. When we add fractions, we need a common denominator of 10. We keep the 10. And these are like radicals, so 7 plus 3 is 10 root 5. And 10 cancels into 10 once, so that becomes a root 5 for your final answer. Give yourself a mark. Number 9, these are like radicals, so I'm going to add the fractions. So you need a common denominator, so the LCD for 3 and 4 is 12. What number will 3 and 4 divide into? Well, it's 12. So I could multiply 3 by 4 over 4 and multiply the 4 by 3 over 3. So I have a 12. For 4 times 3 is 12. 4 times 2 is 8 root 2. Subtract. 3 times 4 is 12. 3 times 1 is 3. So I have them the same denominator. So that gives me, the denominator is 12. So I have root 2's. So 8 subtract 3 is 5 root 2. So it's 5 root 2 over 12. Or 5 over 12 root 2. Give yourself a mark. And we need a common denominator. We're adding these fractions. We have binomial, but that don't make any difference. Binomial numerators. Now, 15, we need a least common multiple. 15 is 3 times 5. 6 is 2 times 3. So that means we need a 3, a 2, a 3, and a 5. We need each one of these. There's only one of each, so that gives me a total of 30. So least common denominator is 30. So you put down the 30 here and the 30 here. Now, what I could do is go 15 and 30 goes 2. 2 times 3 is 6. But it might be better to go 2 here and 2 here. And when I'm doing this one, 6 into 30 goes 5, so 5 here and 5 here. That keeps it better. Yeah, watch. So 2 times 15 is 30. So 2 times 3 is 6. 2 times root 7 is 2 root 7. And 6 times 5 is 30. So 5 times 2 is 10. Let's stretch this out. 5 times negative root 7, negative 5 root 7. Common denominator is 30, so you write it down. And you add these. Now, rather than write all this down again, I'm just going to add 6 and 10 to get 16. And 2 subtract 5 is a negative 3 root 7. Because what I'm doing, I'm adding these together. And when you add, you don't have to change the sign, so it's easy to do. Give yourself a mark. Number 11 is a little bit rougher. Rather than get a common denominator as root 6 and root 2, which is root 12, I like to rationalize the denominator of each of these first. It makes it a little bit easier to deal with. Rationalize the denominator of each of these fractions. Multiply by root 2 over root 2. That gives us root 6 over 2. And when you rationalize this denominator, root 6 times root 6 is 6. And that's a 5 root 6. Now we need common denominator. Common denominator is 6. So I multiply this one by 3 over 3. This is already a 6. So let's see what I have. I have a 6 right here. So 3 times root 6 is 3 root 6. And this is already a 6, so we leave it alone. That's root. Common denominator is 6. And we add these up, we get 8 root 6. So note, we rationalize each denominator, multiply by 3, and we add the numerators, which is 8 root 6 over 6, and that reduces. 2 into 8 goes 4. And 2 into 6 goes 3. Or we could have either or. Again, the key here to make it a little bit better is to rationalize each of these first and then add with the common denominator. Number 12, state the conjugate of 2 subtract root 13. The conjugate is 2 plus root 13. You change the sign of the second one. Rationalize the denominator of each. Well, to rationalize the denominator, we multiply by the conjugate, which is 3 plus root 5, on top and bottom to balance it. So 1 times 3 is 3, 1 times root 5 is root 5. And because these are conjugates, now we can do the FOIL, or we can do it your choice. If you did it by the FOIL, I'm going to do it fast. Because they're conjugates, I can go 3 times 3 is 9, minus root 5 times root 5 is 5. And that gives me 3 plus root 5 over 4. And you can leave it like that if you wish. B, the conjugate of 4 plus root 11 is 4 minus root 11. You also have to do that in the numerator. We multiply, we get 60 minus 15 root 11. And again, for conjugates, and if you did the FOIL, great, but the middle terms are going to cancel out, so it's short way. 4 times 4 is 16. Subtract. Root 11 times root 11 is 11. And that gives us 60 minus root 15, or 15 root 11 all over 5. And notice that 5 divides into 60 12 times, and 5 divides into 15 3 times. So it simplifies. 5 is go into both of these numbers to simplify it. And do a total out of 7. Hopefully everything is going well. Number 14, rationalize the denominator. And the denominator is 2 minus root 2, so the conjugate is 2 plus root 2. Top and bottom. And that gives us, when you multiply, first 3 times 2 is 6. 3 times root 2 is 3 root 2. 2 times negative root 2 is negative 2 root 2. And a negative root 2 times a positive root 2 is a negative 2. Remember, root 2 times root 2 is 2 because it's the root of 4. And the bottom is a conjugates. So the easy way is 2 times 2 is 4. Subtract root 2 times root 2 is 2. That's the fast way. If you want to do FOIL, go ahead. And if that's the fast way, then we simplify the top. 6 minus 2 is 4. And root 3 root 2 subtract 2 root 2 is root 2 all over 2. You can leave it like that. Give yourself a mark. Number 15, simplify the reciprocal of each. So the reciprocal of root 3 is 1 over root 3. Multiplied by its conjugate, root 3 over root 3. That becomes root 3 over 3. Leave it like that. And the reciprocal of remember, let's go back to this one. Root 3 is over 1, so the reciprocal is 1 over root 3. The reciprocal of root 5 over root 6 is root 6 over root 5. Now we multiply by the conjugate, which is root 6, top and bottom. That gives us root 30 over 6. Remember, you cannot cancel here because that's an irrational number. That's a rational number. You cannot cancel here because that's an irrational number and that's a rational number. 16, simplify the reciprocal of the product. Well, the best thing to do, let's find the product first. And then I'll do the reciprocal. So the product is, here comes the product. So we're multiplying. So the 2 into 4 goes 2. The 3's cancel. So the product becomes 2 times 1 is 2 root 6. The reciprocal is 1 over 2 root 6. And we multiply by the conjugate of root 6. Root 6 will do it. So 1 times root 6 is root 6. 2, root 6 times, so that's a 2 times, root 6 times root 6 is 6, so that's a 12. So what I did, I multiplied them first, and then I did the reciprocal. 17, simplify as a radical, no negative exponents. So this binomial raised to a negative exponent is the same as 1 over 2 plus root 3. So a negative exponent of, if you have a negative exponent, it goes 1 over. Remember, that's 2 plus root 3 over 1, so reciprocal is 1 over. And we multiply by the conjugate of 2 minus root 3, top and bottom. 1 times gives you the same terms. And it's a conjugate, so it's 2 times 2 is 4, minus root 3 times root 3 is 3. So that's 2 minus root 3 over 1, which is 2 minus root 3 as your final answer. Give yourself a mark. B, I have a negative exponent with a power of 2. So the reciprocal of 1 over 5 minus root 6 is 5 minus root 6 squared. Notice the reciprocal turns the fraction upside down and you still have a square. And when you square, you multiply it by itself. And that gives you 25. That's the first. Outside is the negative 5 root 6. Inside is the negative 5 root 6. And the last is plus 6. Negative and negative is positive. Root 6 times root 6 is 6. And add, you get a 30 minus 10 root 6. So the reciprocal turns it upside down. And you still got to do the square on it. And you have 6 marks total on that page. Number 18, factor each. Now we have a root 2x and a 7 root 2. So root 2 is common as a GCF. So root 2x divided by root 2 is x, and 7 root 2 divided by root 2 is a plus 7. Notice we're factoring this now over the rational numbers, what we call, or the irrational, which is the bar. So this is the irrational numbers, so we have to take out the roots. Not stress that often, but I like to talk about it and do it. What is a factor of 6 is a factor of 15. I see a 3, but it's a root 3. That's the GCF. Root 3. Because root 6 is root 3 times root 2. And root 15 is root 5 times root 3. So I see a root 3. So root 6x divided by root 3 is root 2x minus root 15 divided by root 3 is root 5. And so we took a root 3 out as a GCF. And in this one, I see a root 7 that's in both terms, and I see an x. So 5 root 7x squared divided by root 7x is 5x plus 7 root 7x divided by root 7x is a plus 1. Notice there's 2 terms here, so it has to be 2 in here. Give yourself a mark. Solve each for x as a radical in simplest form. So that means we're solving for x, so all the x's will move to the left side, and all the numbers will move to the right side. So the 2x becomes negative, and the negative 3 root 2 becomes positive. When we add, we get a 3x. When we add like terms, we get a 12 root 2. Now we divide by 3 on each side. 3's cancel out to give me x. 12 divided by 3 is 4. Perfect. Give yourself a mark. And we're solving this one, but we have to remove the brackets, so the inside can't be simplified. So 2 times root 3x is 2 root 3x. 2 times negative 1 is a negative 2. Root 3 times x is root 3x. And root 3 times root 3 is a negative 3. Positive times a negative is a negative. The x's move to the left side, and the plus becomes a minus. Negative 3 minus 2 becomes a plus 2. And when we add like terms here, we have an x. And 2 root 3 subtract root 3 is root 3 equals negative 1. And now we got to divide by root 3. It cancels to give me x. And we rationalize this by doing root 3 over root 3. So that gives me a negative root 3. Root 3 times root 3 is 3. And remember, you cannot cancel these 3's because that's irrational and that's rational. Number 20. If f of x equals root 5x plus root 10, find the f of 3 root 2 minus 1. So that means we are putting in, if you can see it, the f of 3 root 2 minus 1. That's an x. We're putting that in the place of x, so we're subbing it in here. So 3 root 2 minus 1 plus root 10. Notice it's saying that x is that number, so we're putting whatever this is in the place of x, which I've done. So now we have to multiply before we add. So 5 times 3 root 2 is 3 root 10. Root 5 times 3 root 2 is 3 root 10. Root 5 times negative 1 is negative root 5 plus root 10. And we add like terms, so 3 root 10 plus 1 root 10 is 4 root 10 minus root 5. Final answer. Give yourself a mark. And number 21, find x if the p of x equals root 4 root 2x minus 6 root 2, and the p of x equals 14 root 2. Notice that the p of x is here twice. That means that 4 root 2x minus 6 root 2 must be equal to 14 root 2. The p of x is here twice, so that means that this expression must equal this. That's what we call a transitive property, or you could call it substitution. Now we have to solve it for x. So the x's stay on the left side, and the numbers move to the right side. So the minus becomes a plus, And can't simplify that, but these two can simplify. 14 and 6 is 20, root 2. And I divide each side by 4 root 2. That cancels out to give me a 1. Remember, they cancel. 1 and 1, that's a 1. Root 2 divided by root 2 is 1. 20 divided by 5 is 4. They cancel. And 4 into 20 goes 5. So 5 is the answer. Give yourself a mark. And you have a total on that page of 7. Hopefully everything went well. Total up each page if you're treating it as a quiz to see how well you're doing. And whatever total you get on adding up all the pages, then put it here. Divide 29 into that number. Get a decimal, move your decimal places 2 places to the right and see what percent you got. Hopefully everything went well and you did great. And bring it to the end of the review. If you like my video, click the like button, click the subscribe button, click the notification bell because there's more videos coming your way. Visit my math website, www.mathfullyexplained.com, to find more information on me, my videos, and the content that I have on my YouTube channel. Thank you very much for viewing my video. Bye-bye.